Hi, I'm Briston Wild. This is my submission for LP0013, Token Program Improvements, Authorities, on the new lez-programs repository. I'll walk you through what I built, the architecture, and demonstrate the end-to-end flow against a live lez sequencer with RISC-0 dev mode set to 0, meaning real zero-knowledge proof generation. LP0013 asks for a mint authority model on the lez token program, similar to Solana's SPL token authority pattern. Tokens should support mint authority set at initialization, minting by that authority, and authority rotation or permanent revocation. Here's what I built. First, the lez authority crate, a standalone program-agnostic authority library. This satisfies the RFP001 cross-reference for a reusable authority primitive that other programs can use. Second, I added a mint authority field of type optional 32-byte array to token definition fungible. When the value is sum, the key holder can mint and rotate. When the value is none, the supply is permanently fixed. Third, two new instructions. New fungible definition with authority creates a token with an authority from day one. Set authority rotates the authority or revokes it permanently. The existing mint instruction is now authority gated. If the authority is none, it deterministically rejects. Let me show you the key files. Opening setAuthority.rs. This is the setAuthority handler. It's atomic. All checks happen before any state mutation. If authorization is missing, we return an error before touching the definition. Opening mint.rs. Here's the authority guard. Before minting, we check that mint authority is sum. If it's none, we panic with a clear error message. Mint authority has been revoked. This token has a fixed supply. Opening tests.rs and scrolling to the authority tests module. I've added 8 unit tests covering every authority scenario. Minting with authority succeeds. Minting after revoke fails. Set authority rotates the key. Revoke is permanent, and so on. Plus 7 standalone tests in the lez authority crate, and 2 new end-to-end integration tests in integration tests that run through the ZK-VM. Now let's see it run against a real sequencer. I'm in my LGS scaffold project, and the local net is already running. Watch the top of the output. RISC-0 dev mode set to 0. Step 1 and 2, checking the local net and funding the wallet. Step 3, creating 3 accounts, 1 for the token definition, 1 to hold the initial supply, and 1 for the recipient. Step 4, new fungible definition with authority. Watch the spell output. The instruction is being serialized, sent to the sequencer with program IDs starting with EFDF8, 6B1, and you can see the transaction hash come back. We've just created demo coin with 1 million initial supply and the authority pointing to the definition account. Step 5, mint. Now we're minting an additional 500,000 to the recipient. The authority check passes, so the transaction is accepted. Total supply is now 1.5 million. Step 6, set authority with new authority equals none. The supply is now fixed at 1.5 million forever. No one, including the original authority, can ever mint more. Step 7, the unit tests run, confirming all 60 test cases pass. 7 from lez authority, 53 from token program, including the 8 authority-specific tests. To summarize what's in this follow-up PR. The lez authority crate satisfying RFP001. 2 new token instructions with full atomicity guarantees. 60 unit tests, 2 end-to-end integration tests. Updated IDL, deployment docs, and CU costs. 2 example scripts, and the demo you just saw. Everything from the original submission has been ported to PR125 on lez-programs, as requested by Friar Kraken in the review. The original submission remains linked for context.